All right, we're going to begin with practice exercise 97 today. So get your practice exercise booklets out. Turn to exercise 97. They're on page 27. You may use your calculators, but just basic add, subtract, multiply, divide, some fractions, some decimals. Some might be best worked without a calculator, but it is your choice. You may begin.
I also write the calculator. There ain't no way I'm doing this in my head. Or with normal math.
Just make this a nice even dollar.
Yeah, that sounds good.
Watch him grade this one.
Let's go and take a look at these together. Ethan was finished first. So Ethan, let's start with you. Going across the top row, you had some decimals to add, subtract, and if you were doing it by hand, you'd want to make sure you lined up the decimal point. When you're doing it on the calculator, it really doesn't matter. What did you get for your answer?
5.876.
5.876. Same for the next one.
147.285.
147.285 is correct, and the last one on that row.
17.5624.
Good, 17.5624. All right, next row, going across, you had to multiply some decimals, and if you were doing it by hand, you'd want to make sure that you accounted for the number of decimal places appropriately, 5 in your answer. But you didn't have to worry about it, and the calculator took care of it for you.
0.0314.
Good, 0.0314. Now there's technically another 0 at the end of that to make the 5 decimal spots if you were doing it by hand. The next one, honestly, maybe could be done just as easily by hand as it could on the calculator, except, again, keeping track of the decimal point.
4.75.
4.75, very good. The next one, not a hard problem to do by hand, but again, easier with the calculator as long as you know how to enter fractions.
7.
7, our answer. Good. Next row, what do we get for our first answer?
0.37.
0.37. Now this next one,
57,000.
oh, you entered the wrong button of the calculator. All right, so Genesis, are you good so far? You are not. Chris, good so far? No. Quentin, good so far? All right, Christian. What?
The guys first.
Chris and Quentin. All right.
Whoa.
Quentin, what did you get? For
5.7.
5.7 is our answer. And honestly, that could have been done more easily without a calculator. Honestly, just move the decimal 2 places. All right, how about for the next one?
13 and 1 11.
No.
I think you multiplied. I think you did on that problem what Ethan did on the previous problem, where you multiplied instead of dividing. Let's see, Jamie, are you perfect so far? All right, what did you get?
2 and 311.
2 and 311. So let me read that row back to you again since we had some trouble. 0.37, 5.7, 2 and 311. All right, bottom row, Jamie.
8 and 7/15.
8 and 7/15 correct. The next one?
0.000002.
Good. 5 zeros and then the 2, 6 total decimal places. And again, could have done that one in our head more easily probably than even putting it in the calculator. And the very last one,
9 and 1/9.
9 and 1/9 is correct.
Dang it.
Just missed the one. Anyone else just missed one? Just missed one. Okay, many of you. All right, questions at all on that? Again, a little easier since we did have the calculator this time. Yes, ma'am.
When I did the second one on the last row, my calculator gave me 2 and then -06 like in the corner.
Ah, okay, so your calculator put it in scientific notation for some reason. Let's see if I can...
Your calculator's a clown. Can't believe I had to multiply that.
I'm not sure how to take that off for you. I don't know. All right. Let's go and pass those forward, if you would, please. We'll worry about that more another time. Take your hexagon handouts out, if you would, please. You had a hexagon, something like this, on your handout. You're supposed to construct a similar hexagon on the given line, A prime, B prime, as your base. And you've never done a hexagon before. We've done a couple of pentagons, we've done a quadrilateral, never done a hexagon before. But the idea, remember, was just stay with the steps. Do what you know to do, follow the process through. It's just going to take just a little bit longer. I'm going to fold up the hexagon so that I can see that it is completed. Something went a little bit awry for you there, Quentin.
I lost my thing, so I said
We did it. Okay. Ethan is trying desperately to find something that looks like a pentagon hand or a hexagon handout. While he is searching, let's go over to Quentin. Quentin, what do we need to do first if we're going to copy or construct a similar hexagon over here?
Draw the diagonals from A to D and A to C. Or draw the diagonals from one side of the base.
Okay, from one end of the base. In this case, you said A. How many diagonals can I draw from A? 3.
That's what I said.
Yeah, AE,
I forgot that too.
AD, and AC. Give me just a moment there, Ethan. Just hold it for just a moment so I can see it. Glance that way. All right. There we go. All right, so I've got 1, 2, 3, 4 different angles in this instance that I am going to have to try to copy. And so Quentin, walk me through what I should be doing here.
Just point the compass on A, and then make an arc. Copy that arc on A prime. Mark off the whole arc.
All right, so this will give me the entire angle at A first of all. All right.
Then mark off the next one.
Good, then measure it down to just the first 3 angles. This will give me the placement of my diagonal. And then of course, yeah, A to AD, that'll give me the next diagonal. And then finally, AC. All right, and of course, when I draw these lines, the recommendation, especially the diagonal lines, not so much this one, but the others, should we draw them nice and long? Give yourself plenty of room to work so you don't have to go back and extend them later, because nobody wants to do more work than they absolutely have to do. Because we are quite so. How many started off this way? Good, most of you said. And again, that's why I say it's just like the pentagon, but a little bit more work, meaning there's an extra diagonal in here, and later there's going to be one extra angle to copy. Let's see then what, Jamie?
And then we copy the angle at B.
Good. So we'll get this big obtuse angle here. And again, when you copy the side, make sure it goes up to hit the diagonal. You don't actually have to extend it through. You just have to reach it there. All right, and that has located now point C prime. Ethan, now what?
Copying.
The whole thing?
No, I don't do that. I don't do. You can, but you don't.
Right, you can. You can either do the whole angle C, or we could just, if we call this angle 5, we could just copy angle 5, right? And it sounds like that's what you did. All right, so there's the arc. So lots of make an arc, measure across, and connect the dots. And again, when you connect the dots, that'll take you to point D prime. And then Audrey, good, the second half, that angle is 6. So more of the same thing again, though my compass needs to be able to fit on, ooh, just barely made it, on DE. point E prime. So basically, class, you get the idea. This method works regardless of how many sides are there. It just gets really long and tedious if, say, we were trying to do a duodecagon or something. All right, which is why we usually did, 4 or 5, maybe 6 sides at our most, just because we're lazy, don't want to have to do quite that much construction. But it's not that the process is any different. It just takes longer. Lots of copying angles.
Bonus question on the test.
Now there's a thought. You couldn't hear it on video. Chris said bonus question on the test.
Bonus question.
Construct a
Turn around.
duodecagon similar to the given duodecagon.
It'll take us a couple hours, but we'll get there.
I want to make sure you finish the rest of the test first. It's not going to be worth that many points. And there was angle 7 that
So
we
you were
copied.
12 points.
And there we go. And of course we've got some lines extending out of it, but similar to the given. And that's what our goal was. Questions on this. All right, set that aside. If you would, take out your textbooks, turn to page 226. Page 226. And also have out some paper, if you would, please. On your paper, I want you to draw 3 lines of varying length. Let's call them A, B, and C. 3 lines of varying length. Let's make them A, B, and C. Let's make them progressively larger. So we'll start with a shorter line segment A and get progressively longer each time. Page 226, we're going to look at the very bottom section of the page, exercise 4.23, and go ahead and read that for us if you would, Audrey.
Number 1. Given 3 lines A, B, and C, construct x equal to 2 times b over c, x equal to 8 times c over 2b, x equal to 2 squared over c, and x equals 8 times b plus c over c. In each case, write the corresponding proportion between x, the last one with construction.
All right, so they're telling us what construction we're going to use. We're going to use construction 17, and that's the construction of the 4th proportional, which is why it says in each case, make x the last term of the corresponding proportion. So let's start with our first construction, which is to make x equal to the product of a and b divided by c. How would I make this a proportion? Kendall, there's a number of ways you could do it, but kind of talk me through your thoughts.
A is to c as b is to x.
All right. Would that give me a times b? No. Because the a and the b need to somehow stay together. Why don't we do this first, Kendall? Why don't we unmuddy the waters a little and just make it so there aren't any fractions in front of us first? What would it look like if there were no fractions up here?
A times b is 2c x.
Yeah, if we were to multiply both sides by c, I guess what I was thinking is just clear the fraction out. Just like we did in junior high when you first learned about clearing an equation of fractions. Just clear the c out to get cx equals ab, right? Now what we've got, Kendall, is the product of 2 quantities equal to the product of 2 other quantities. And I think if you can get to this point, it'll make the proportion a little bit easier to set up.
C is to a as b is to x.
There we go. That'll work there. Do y'all follow where we're at now? If I can construct that proportion, then the x that I construct will equal a times b divided by c. At your seats, go ahead and construct that proportion. Using construction 17. should not have made my line segments quite so long, considering my compass can't reach. Chris finished?
Mm-hmm.
Audrey finished? And your fourth proportional should be even smaller than your segment A. If your lines are getting progressively larger as you saw there. Questions on this construction? All right. The fun of it, of course, comes in deducing the proportion even more than the constructing thereof. Let's go and take a look at the next one where we want to construct x equal to a times c divided by 2b, or not 2b. Let's see here. Thoughts on how I could turn this into a proportion, Chris?
A is to C as B is to B.
Well, let's start, like I said with Kendall, let's just make it so there's no fractions to worry about first.
Okay. Times the 2B over to the X.
Right, so we get
2B X equals AC.
There we go. And what we want to do is we want to think of 2b as one single quantity. I think if we can think of it as a single quantity, we'll be good. All right, so Chris, now what proportion might we set up?
2b is to X as A is to C.
2b is to X as A is to C.
I'd rather it be B is to B, but I don't think that's going to work.
Yeah, well, here's the problem, Chris. Remember we said if a pair of values is equal to another pair of values, one pair may be used as the means and the other as the extremes. That's not what we have here. The 2b and the x did not stay together. You've got the 2b paired up with the c.
2b is to A as X is to C.
2b is to A as x is to c.
Yeah.
So we keep the 2b and the x together, and we keep the A and the c together?
Flip it.
Try again.
2b is to A as X is to C.
All right, so we've got the 2b and the x.
No, it's X. 2b is to A as C is to X.
All right, so we've got the 2b and the x together, and we've got the A and the c
I haven't
together.
slept in 2 days. So
All right, does it make sense now?
Yes.
Now, here's the question. We're not going to take time to do the construction, but if I were to take time to do the construction, how in the world would I 2b? I see b. How would I make it 2b? Quentin?
Mark off B once and then mark it off again.
Right, you literally have to measure off of b, mark it once, b, mark it twice, and this would be the end of 2b. You would then need to mark off A, and where would you mark it off?
Second B. At the end of the second B.
Right, on this same line here. So there's your 2b is to A, you'd mark off your longer segment C, and then again, you're not going to connect here to here, but here across. Does that make sense how we would have to construct that? Questions on that?
Why wouldn't, yeah, I have a question.
Yes.
Why wouldn't you do it to the first B?
Because it's not B is to A as C is to X. It's 2B. This whole thing is 2B. 2b is to a,
Oh, I see what you mean.
as c is 2, and then of course when you made the parallel, there'd be your x. Does that make sense? Yes.
So when I used my freebie yesterday to go look for that, I didn't find it. Is that still considered using my freebie?
Yes, because you left the room. All right, let's go ahead and take a look at the next one where we had x is equal to b squared over c. Genesis. Again, the real fun in this is coming up with how to do it. We won't necessarily take time to do this construction, but how would I set it up to get ready for the construction? Thoughts?
Give a fraction.
Okay.
So, divide, or the c. So c x equals b squared.
There we go, multiply both sides by the c to get cx equals b squared. And then how might I make this into a proportion though? Because normally if the product of two quantities is equal to the product of two quantities, all I see is a single b squared right here.
Well, then you do c to e and b is to x.
There we go. In seeing a b squared, we understand that means the same thing as b times b. So yes, c is to b is b is to x. So again, in the construction, we mark off the c followed by the b. On the next side, we mark off the b and then construct. Now, technically, it's not a fourth proportional here, Genesis. It's a third proportional. Good, since we have the mean proportional questions on this that Genesis talked through. Now for a fun one. X is supposed to equal a times the quantity b plus c all over c. Ethan, thoughts on how we would make that happen?
I already have a headache. What is it, fraction? So, cx equals ca, no.
Right. If you multiply by c, you get cx. If you multiply by c, it just cancels with the other one. So we get this.
ab plus ac.
But let's not distribute that. That would make life very challenging, I think, for us. But if we leave it like this, Ethan, then what we see is a product of two quantities and a product of two other quantities, so that we could still make a proportion out of this.
C is to you wouldn't say AB, would you?
No, we wouldn't say that.
A times 8. I'm so confused. The whole thing under C.
What whole thing?
A times B plus C.
No, we wouldn't do that.
Of course we would.
Quentin, help him.
C is A is B plus C is X.
There we go.
Isn't there an easier way
Here's
to do
two
that?
quantities here, and here's two quantities here. Does that make sense now? Now, Ethan, if we were to actually construct this, we would still draw our two lines, right? But the first thing we would do is measure and mark off C. So we measure, mark off C. Okay, so C is done, then what would we mark off? A. So we measure A, and we mark off A. Then what?
B and C.
Right, we'd have to measure off B, but that's not our key point. Then we mark off C, so this whole thing would be B plus C. So there's a point, there's a point. I'm not worried about the end of B, but the whole B plus C as one entity. Then when we constructed the mean proportional, or the fourth proportional rather, there we get our X. Does that make sense now? Okay, question, Chris.
Can instead of doing B plus C, can you do C times AB equals AC times X?
Who? Say that one more time, I'm sorry.
Distribute, can you do AB plus AC?
Well, the problem would be how would you put that into proportion if you did? Like if you said CX equals AB plus AC, that's not wrong, but how would you set up a proportion with that? You can make a proportion when you have a product of two quantities and a product of two other quantities. But now I have a product of two quantities equal to a product of two quantities added to another product of two quantities. Now there's no proportionability, which takes out the element of being able to construct it. Now I will throw this thought out there, Chris. Suppose we wanted to construct X equal to AC plus BC all over B. How in the world would we make a proportion out of it? By doing the opposite of what you were suggesting, right? Instead of distributing because it would mess things up, well, here we need to undistribute, right? Here we would need to factor out a C. And then, of course, we could say that B is to C as A plus B is to X. And it would all keep everything together. So you'd actually do the opposite. You could use factoring in some instances to create the ability of making a proportion. Okay, questions on this? Just a little bit of creativity to using construction 17. I wanted to point out to you questions there. Let's take a look at, we're going to keep our lines A and B. You can go ahead and erase your lines here to scribble it out or not worry about it at all. I'm going to go ahead and erase it though. And look at number 2. And what are we trying to construct in number 2? Ethan, back to you.
Construct x equals, that one, right?
Mm-hmm.
X equals square root of 8 squared plus b squared. Use theorem 62.
Construct x, so it's going to equal a squared plus b squared. Thoughts, Ethan, on how I could construct x equal to the square root of a squared and b squared?
You square x. Would you do that? Square x and then x equals, x squared equals a squared plus b squared.
All right. Truly, that's where this would come from, right? Would be coming from here. You'd end up having to take that square root. What does this look like, Ethan?
Equation.
Yes, Genesis. You put your pencil down in disgust. Help him out.
I know there's two because I'm thinking of both of them. I know there's like the perfect square.
What?
I know it. It's in my brain.
Are you sure about that?
Yes, I do.
Pythagorean Theorem.
Pythagorean Theorem.
Yeah, I said that.
Yeah, of course you did. Yeah. It looks like the Pythagorean Theorem, doesn't it? Except instead of a c squared, we're calling the line we're going to construct x. And so in other words, class, a and b, these square whatevers, those are simply my legs. These are simply going to be the legs. So these two lines then on your paper, the A and B, simply need to be the legs of a right triangle. And if we will construct the right triangle, x will be the hypotenuse. Good, Kendall. So at your seats, let's go ahead and construct a right triangle. What do you suppose we should do first here, Kendall?
Right angle.
Okay, how do I make a right angle?
Perpendicular.
Perpendicular. So let's start by drawing a line. Let's make a big long line. It's a great way to start. And so Kendall, kind of talk me through this here.
Can you start the perpendicular to the line?
All right. Any particular place we want to put our perpendicular? How about, is this okay? Right there? Is that a good spot? Okay. Let's put a perpendicular there, Kendall.
You put it in front of the compass on the point, and then you open your compass. No, smaller than the smallest side. Yeah, and you make arcs right there and on the other side. And then from those intersections, you open your compass one, and then make an arc above and below.
I don't necessarily need to go below. It's not wrong to go below, but I'm lazy. And so yeah, there's our right angle. Now, I don't have a right triangle yet, but I at least have a right angle now. All right, so now what do you suppose we should do, Kendall?
You measure A.
All right. Got it?
You mark it off on the right angle. Right.
The bottom or the top?
Bottom.
Okay. Like that?
Yeah.
Okay, so that's A right there. All right, then what?
You measure B.
Okay.
And then you mark it off on the other side.
Like this? Just like that? So, that's B?
Yeah.
Okay, then what?
Right?
Okay. Like that? And what do I call that? X. Right? And now the line I just constructed is going to equal the square, the sum of the square root rather, of the sum of the squares of the two lines that you drew. If you were to measure it and do all the math, there we go, it has to work. Pythagorean theorem, yes sir.
Couldn't that also just be x equals a plus b?
No. No. X equaling the square root of a squared plus b squared is not equaling a plus b. X equaling the square root of a squared plus 2ab plus b squared would equal a plus b. Because this would be a plus b quantity squared. Good question though. All right, questions on that? Does it make sense to use the Pythagorean theorem? All right, how about this? I'm going to deviate slightly because I told you to make your lines progressively longer, right? Now, if you look at the next part of number 2, it says A needs to be greater than B. So we're actually going to flip-flop some things. How would we construct X so it's equal to the square root of B squared minus A squared?
X squared equals b squared minus a squared.
Okay. Is that the Pythagorean theorem again?
No.
Not
No.
quite.
But
But it's close. Thoughts, anyone?
Invert signs, but that would make the x squared negative.
It would. And it would make the B squared
Yeah,
negative.
that's not right.
shouldn't you like
Move
add a
negative
squared?
a squared.
Yeah, move the A squared over to the other side.
B squared.
Ah, okay, so now all of a sudden, class, A and B are not my legs.
B is your hypotenuse.
B would have to be the hypotenuse, A would be
leg.
and in my right triangle, the side I'm trying to construct, X would be the
Other one.
other leg. At your seats, go. I'll do it on the board, but you do it at your seats. So this time X is going to equal the difference of the squares of the two given, the square root of the difference, excuse me, of the squares of the other two lines. Still making a right triangle. But this time, X is not going to be the hypotenuse, but rather one of the two legs. All starts much the same way. Pick a point, put a perpendicular there. From that point, measure off A. The difference is the placement of B. Kendall, everything I've done so far is exactly the same, except when I got to this point last time, I put B right here.
And you put a point of your compass on the other arc of A, and then measure out.
There we go. We're going to measure across this way for B to make sure that B winds up as the hypotenuse. And so now, Kendall, what do I call this other leg? X. Yep, and there we go. I've constructed a line equal to the square root of the difference of the squares of two other lines. Questions on this? Questions? Look at the next page. Let's look at exercise number 3 here. It says to construct x so it equals the square root of 2ab. Now we've got the same line A, same line B we've been using over and over again. But this time it's not like b squared minus a squared or a squared plus b squared, it's just 2ab. Thoughts on how we construct that?
X squared equals 2ab.
All right, let's get rid of the radical. X squared equals 2ab.
X times x equals 4b times ab.
How about 2a times b? ab times ab, a squared, b squared, right? So 2a times b. So Quentin, you've done all the hard work. Now it's time for the easy job.
Draw a line and then mark off a twice and
Proportion.
X is the 2a as b is the x.
Yeah, there's just one little teeny problem.
X
I draw a line, I mark off at.
X is mean proportional. Yeah, x is mean proportional.
Mean proportional, right. So not x is to 2a is b is to x, but rather
2a is to x is b.
there we go, which remember the mean proportional is not this picture at all, is it? The mean proportional, remember, is that sideways triangle with the semicircle and stuff. Let's go ahead and do this as we finish out the hour. So we need to start by drawing a
Line.
rather long line this time. And what will we mark off on our long line, Quentin? Good, A twice before you put your dot. Mark off A 2 different times before you put your dot. 2 times in succession, I should say. So there's A, I don't care about that. There's another A, that's what I care about.
And mark off b in succession.
Good, and then B. So there's 2A. Bless you. There's B. And there's extra. All right, now what?
Which point of the compass on A?
A?
Second A. 2A.
End of 2A, there we go. And make a
Perpendicular to that point.
perpendicular, there we go. I reckon when the bell rings, you'll be dismissed. We're going to be done in just a moment. In here, stay with me through the bell. And now we're ready for our semicircle, right? There's just one little thing we need to know before we do the semicircle, class. The midpoint. And to get a midpoint, we need a perpendicular bisector. And again, technically, you don't even need the entire semicircle, though you're welcome to draw it if you like. We really just need that mark. So that we can identify x exactly equal to the square root of double the product of your two segments. questions on that? All right, your homework for this evening is just to do some reading. Just to do some reading. I need you to read over pages 231 to 236. Read pages 231 to 236. We'll take a look at that material that you're reading tomorrow, as well as just a little bit more information that's not necessarily on the in the homework reading. There's one more concept, but the reading of it would have been really short. All right, have a great rest of your day.